Hi folks, my name's Emily Weber. I'm a machine learning specialist at Amazon Web Services, and today we're going to learn about Hugging Face on SageMaker. This is your deep dive. And this is the second part of a 3-video series. Our first video is about an introduction to the Hugging Face Transformers SDK and about all the ways to use it on SageMaker. In this video, we are going to deep dive on training. We're going to learn all about distributing across multiple GPUs, multiple server nodes. We're going to look at SageMaker Training Compiler. We're going to understand the hyperparameters and the model selection that is most optimal for different use cases you're interested in. And then the third video is about hosting. So let's get started. All right. So there are 3 modes of Hugging Face models on SageMaker. You can fine-tune your model, you can scale your model, and you can train from scratch. And you can do all of those using this Hugging Face deep learning container. So you remember we learned about this in that first video where essentially, again, there's a pre-built deep learning container that is available to SageMaker customers, and that uses the Hugging Face base images and the base content. Now we're going to pass in a handful of hyperparameters to that container. Now the hyperparameters are generally pretty consistent. You want to pass in the name of the model that you're interested in. You need to pass in the directory for that model. Now remember, in SageMaker training, we pass a lot through that opt.ml. That's actually an indicator for the path within the training container itself. You'll see this do train parameter. Pro tip, this is how you tell your model to train or not. If you don't have it here, odds are it's not going to be training. And then the dataset name. So the dataset name is especially relevant when you are using a dataset that's coming from the hub. So remember, the Hugging Face hub has pre-trained models, has tokenizers, and has datasets, all of which you can easily download. If you are using one of those and you pass it here as a hyperparameter, the SageMaker training container will download it from the hub on your behalf during training. And so it executes again during the training config. When you are bringing your own data, so say you're bringing your own support ticket classification data, or your own customer search data, or your own documentation data, all of that you can bring, and then again fine tune that base model. Next, we have this very handy parameter called a getConfig. So this getConfig parameter is pointing to the Hugging Face repository. So again, it's pointing to the Hugging Face Transformers GitHub repository directly, and the branch, so you know the version of the Transformers SDK that we're using, and you'll see 4.6.1 pretty commonly. So again, we're pointing to that base getConfig. And then in my estimator, I'm pointing to the name of a script that is sitting in GitHub. I do not have this script locally. The script is not sitting in a local file, it's sitting on GitHub. And then in the source directory file, our parameter, I'm passing in the directory, so the path of this script in that repository. And this does not just work with Hugging Face. This works with any Git that SageMaker has access to. And so you can just pass in Git configs to train rather than strictly training scripts. But in any case, we'll do this with Hugging Face right now. Next, I'm using, this is a P3.16 XL, so this is a healthy machine with 8 NVIDIA GPUs, so definitely good for scaling. We're using one machine here, got my SageMaker role, config, different versions. And then again, I call model.fit, and so we're going to fit this model, and again, we're going to turn on this new instance in order to download that data set. If you're thinking, well, that sounds like a lot of work, how do I get that code? You can generate the code configs for SageMaker on Hugging Face. So in this little snippet here, I'm going onto the Hugging Face model site, and then again, I picked Distilabert GPT-2, and then you're selecting the task. So token classification, text classification, whichever you are looking for. And then you just determine if you're training from your local machine. So that means basically being on your laptop or even on Studio, like in local mode for notebook instances. And so here's another repeat on this same thing, right? So you go to the model, you pick train, you pick SageMaker, And then you pick the task that you're most interested in. Really doesn't matter, whichever one works best for you. And then the config for that. And so pick AWS, and then just go ahead and hit copy. And then when you hit copy, again, you can just paste that directly to your Studio notebook. And so another SageMaker feature you should know about is the training compiler. So we launched training compiler at reInvent last year. That was 2021. And the training compiler is going to compile your Hugging Face models. So for supported NLP models within the Hugging Face family, we have about 50 models that are supported to date. And essentially, when you use the base trainer API, so when you're using that trainer API from Hugging Face, there are 0 code changes required. The only code change that we ask is that you pass in this training compiler config. So essentially in your estimator, pass in this training compiler config, and we will take your model and we will literally make it smaller. Essentially, there are a number of different compilation methods, and essentially what is going to happen is that we're looking at the profile of your model, and then we're placing different pieces of your model on your hardware in a more optimized fashion, just to utilize less and less memory to give you more memory for larger batch sizes and faster training. So SageMaker Training Compiler delivers up to 50% faster overall training. We can also distribute our Hugging Face models across many GPUs. So it's a really exciting time where, we see, obviously there's so many NLP startups out there, and there's so many, models that are running on thousands of GPUs, tens of thousands of GPUs. You'll see very aggressive training schedules. And so we recently completed a test with a 175 billion parameter NLP model on SageMaker. We scaled this on 125 machines. We saw 32 samples per second. So we were able to deliver that for 175 billion parameters. And we projected if we scaled that up to 240 P4 instances, that would take 25 days to train. And the good news is that distributing this with Hugging Face and SageMaker is really easy. So on the right-hand side, we'll look at, this time we're using a PyTorch container. So based on the different versions, you may use PyTorch container, or you may use the Hugging Face container. At this point in time, I need the PyTorch container. So I've got the PyTorch container loaded. Here, I'm going to train GPT-J. So I have a GPT-J script using SageMaker Model Parallel, and we're going to run that on a training job. And so that's the estimator view, so not much change. But then in the SageMaker distributed, you'll see I have quite a few hyperparameters. So let's try and unpack that. So with Model Parallel, Model Parallel means I'm going to take my model and I'm going to break it up, literally splitting my model in half or in thirds. I'm cutting it up into pieces, and then I'm placing different pieces of that model on different GPUs. So one overall model that's using multiple GPUs, and that's good for both single servers and multiple servers. So if I have one, P3.16XL, that's 8 GPUs. If I have two, that's 16 GPUs. What I would do is set partitions to 16. And then what's happening is SageMaker Model Parallel, we're going to profile, again, the algorithm that you bring, in this case GPT-J. We're going to break it up into multiple parts and place those parts literally on the different devices. So that is Model Parallel. That is a sister product to what's called Data Parallel, SageMaker Data Parallel, which actually makes copies of your model. So Data Parallel is useful when you have small models. If you have models that are typically 1.5 billion parameters or under, Data Parallel is an appropriate approach where you can scale out copies of that model onto multiple GPUs and multiple servers in your overall training job. Versus, again, SageMaker Model Parallel, we're just doing that at the GPU level. So both of those are easy to set up with Hugging Face because Hugging Face actually built in their base trainer API. They built an integration to SageMaker Model Parallel and Data Parallel. So commonly you'll just set Model Parallel as enabled, and then they'll pick it up from the back end. And with that, let's take a look at a demo. All right, so here we are. So we're still in SageMaker Studio. We're sitting here in USC Swan. The notebook I am using is a public notebook. So this notebook is coming directly from the SageMaker examples. And we'll just show that out here. So again, we're using the SageMaker examples. And then we'll cruise down here and we'll click on training. So that training folder, distributed training, PyTorch, model parallel, GPT-2. So that's what I'm running right now. And let's just zoom in here. Actually, that's pretty good. So great, let's check this out. So in this notebook, we're gonna do similar steps that you've seen before. We're installing SageMaker experiments right here. And then we're getting the config set up. So we've got our Boto 3 client, our session, our region, SageMaker session, default bucket, all the normal pieces. And then we're going to point to S3. So this notebook, we have two modes for running this notebook. One mode of running this notebook is on a very small sample data set, which is not intended to train what we call to-convergence. So it's not going to train your entire model. It's just to show you that things work. You can indeed distribute your model. You can indeed, get this piece to run. But if you want to run it to convergence, essentially, you'll switch out some of these parameters and then actually run a script to download a very sizable data set and do some local processing and then land that in S3. So that's the other option. And also you can point to FSX. So remember, FSX is an optimized file store for AWS generally, FSX for Lustre. In SageMaker, we can train on FSX actually. So when you're working with larger data sets, really anything beyond 50 gigabytes, I would look at trying to put that into a SageMaker FSX for Lustre file store. That's because two reasons. Number one, the data download is just so much faster. Like part of your job wait time actually is just waiting for the data set to be downloaded from S3 to your SageMaker training cluster. So when you use FSX for Lustre, that wait time is gone because you have this file store. So there's an offline creation where you create the FSX for Lustre file store off of what's sitting in S3. And so in this case, we're not going to do that, but you can, again, create that FSX for Lustre. And then your training is just going to be faster because essentially it's just a much better iterative experience. So like your instances come on and they just attach to your FSX for Lustre volume rather than waiting for that copy in from S3. So that's an option. Yeah, there we go. Great. All right. So now let's take a look at these hyperparameters. So there are a lot of hyperparameters here. What's going on? So actually, if you cruise down, you can see the model config, which helps fix ideas a little bit more clearly. So there are three different modes for running this. So GPT-2 small, GPT-2 30 billion parameters, and then XL. So these three different model configs. For each of those model configs, we strongly recommend changing the hyperparameters. And so as you are working on this at home, as you have your own, Hugging Face text classifier or translation algorithm or question answering solution that you're working on, as you scale up that model, I need you to change the parameters. Actually, I need you to change out the overall size of that model and how you are defining that using SageMaker distributed frameworks. So tensor parallel, pipeline parallel, all of those, you need to modify those as you increase the size of that training job. And we have notes about doing that in our documentation, so fear not, it's all very well documented. But so now that we know we've got three different models here, so these hyperparameters are consistent as a base for all of them. So essentially the logging frequency, how frequently we want to do our checkpointing, some of our learning rate specifications, total number of steps, using Wikipedia data, etc. And then the MPI options are specific to SageMaker Model Parallel. They essentially optimize it more efficiently. And then, great, yeah, so our model configs. So again, 30 billion, which is very large. Like the 30 billion is not a small model. If you were doing this, I would say, and again, it's great that we start with this. So start with GPT-2 small, then increase to GPT-2 XL, and again, that's 1.5 billion. And if and only if that seems promising, so after you've proven out some value at GPT-2 XL scales, then and only then increase your size. And honestly, that's a pretty big jump going from 1.5 to 30. Like, I might consider 1.5 to maybe 13 billion parameters is a more common sort of middle step. So definitely increase the size of your generator as you get fruit from your experiments as they're shown value. So that's that. So we're gonna set up Studio, just create this experiment. And then here we go. Yeah, so this is one P3.16XL. And so you can increase, again, the number of instances. And then the volume size, in this case, does need to be pretty sizable. And then we'll create this estimator. So here we go. So in this case, I am using a local script. So in that first video, we pointed to GitHub. In this video, I have a local script, and we'll look at that in just a little bit. So I've got my local script here. I've got my P3.16XL right here. The size of my volume, so that's the size of the EBS volume on my SageMaker training container, the number of them, and then here are all those distribution parameters. So if you're using model parallel, you're gonna need to have MPI enabled. Processes per host, etc. Yeah, okay, tensor parallel. So tensor parallel is an addition to model parallel, essentially. So remember, model parallel takes your model and breaks it up across GPUs. Tensor parallel takes specific layers within that model and breaks those up and places them on multiple GPUs. So if you have one or even a few extremely large tensors within your model, tensor parallel will break those up and place them more efficiently. And so that's your tensor parallel degree. Then we have partitions, optimizer state, etc. Those are all defined here. And again, with the hyperparameters, the most common thing to do, number one, is to look at the research paper for that model and just reuse the same hyperparameters. Like, maybe do some small modifications to get it more optimized for your training job and your data set, but on average, most people just reuse the hyperparameters from the research data set and from the paper, and also use our documentation, like heavily use the SageMaker documentation for distributed training. It is excellent. they've really they've done an excellent job on our documentation for distributed training. So look at that, spend time thinking about it, cut tickets there if you have any questions. It's really useful. So in our estimator here, so again, we're specifying our framework version, the model of Python, or the version of Python rather, our checkpoints, and onward ho. So then we're going to call model.fit. So we call model.fit, and then this should look pretty similar, right? We're installing the requirements, and then we're downloading all of our SDKs. Things look normal. Got our P3.16XL in there, then a reprint on the hyperparameters. And I'm going to try and zoom down because I want to show you the ranks. So the ranks are your GPUs, actually. They're the different devices that are available in your cluster. So remember, we have one P3.16XL, which means I have a sum total of 8 GPUs. And so if I start at 0, I'll make it up to 7. So those are my 8 GPUs. And so what model parallel is going to do, remember, it's taking that GPT-2, and this is a small GPT-2, but we're going to take it and we're going to break it onto the partition. So I have 12 layers assigned to partition 0. And then essentially pieces are going to execute on different ranks. Right, so there's my partition 0. And we're just going to zoom ahead here. Okay, and so we've got some action happening. So that's our loss, that's our speed per batch. here we go. And then we're storing the ranks. Again, we're storing the gradients and the values for each of those different ranks. So again, SageMaker Model Parallel is managing that distribution for you. And how does it do that, you ask? Let's check it out. So we're going to go into that train GPT simple script, which is sitting right out here. And let's just see if we can unpack this a little bit. So remember, this script is available on GitHub. It's just in the SageMaker examples. Anyone and anyone can access this. But let's see if we can unpack this. And we're going to start at the bottom, since that is far and away the easiest thing. Okay, so we've got a main function. Let's see if we can find the main function. So the main function is, should be, yeah, here we go, right here. So our main function, so we're going to start with parsing those arguments. So that's nothing unusual. And then that SageMaker Model Parallel config is right here. So that's using distributed data parallel, which is right here. And then basically just applying those hyperparameters. Remember, so everything we loaded in through args, the micro batches. So the micro batches are splitting. So one batch is a part of your epoch. So one part of your overall data set that's passed on to the model. A micro batch is a split in your batch, actually. So a micro batch is taking your overall batch and then sharding that out to your different ranks. So in this case, the number of micro batches is basically your overall batch size divided by the number of devices that you have. So your batch size divided by 8 for an 8-device machine. Checkpoint activation, so a couple other new SageMaker Model Parallel features, and onward. So we're going to initialize SageMaker Model Parallel right here, smp.init. And then if we're on the main rank, make sure that's where we do our saving. Yeah, if local rank is this guy. And then we're going to load in that GPT-2 config. Where does this come, you ask? It comes from Hugging Face. Hugging Face has a GPT-2 config. So we're using the Hugging Face SDK. If you want proof, let's go look for that. GPT-2. Oh, perfect. That's what I was already searching for. So where does that come in from? From Transformers. Remember, so Transformers is that Hugging Face SDK, and we're importing the auto model for causal language modeling. That's the objective that we use for GPT-2. It uses the previous tokens to generate the future tokens. That's why they call it causal versus mass language modeling, which is bidirectional, and that's what you've seen for BERT. And so in any case, we've got our GPT-2 config set there. And so in the script, so we load our config. So here they're hard coding in the vocab size. So pro tip to modify this to parameterize that guy. But in any case, that's the vocab size that they're using. And then, yeah, so then we're going to pass in our different arguments for the context width, number of positions, number of embeddings, number of layers. So again, we're actually changing the architecture of this model based on the parameters. The activation function is defined right here, the embeddings, the attention, etc. Yeah, so that's your GPT-2 config is right there. And then we're gonna load that in. So so then we're just gonna set our seed. We're gonna turn on tensor parallel right here. So with smp.tensorParallel, get that turned on. And then, again, if it's the rank, just print out the total parameters. We're going to set our device right here. So you'll see this quite a lot in the SageMaker Model Parallel framework, which is you take your model, and then you're going to load that as an argument to SMP. So again, SMP is the SageMaker Model Parallel SDK. And so we're going to load that base GPT-2 model into this framework here. And then we'll go a little bit further down. And so we'll keep determining, so we're setting our optimizer here, turning on activation checkpointing, all of which, again, beautifully documented. And then we've got our optimizer determined here. and then we're going to load the optimizer as well into that model parallel. So again, SMP dot distributed optimizer will load that optimizer in here, define our learning rate schedule, and then we'll load those in. So we've got our function, load, model, and optimizer, and then essentially we're going to define all these pieces and then call train. So then there's this train function, and then and that train function includes the logging. So we get to see all of the action that's happening per step. And then once that has completed, we'll save the final model, again, just on that first rank. And we'll save that, and that's our script. And so that is what's running, again, on the SageMaker training clusters. And if you want to see it in the console, again, that's going to be right out here. So we'll look at our SageMaker training jobs. This is my SMP GPT-2 small model, and again, that's on a P316XL, and I can see my training image. I can see my training data sets. So there's that train S3 path, and then my test S3 path right out here. My model finished, and then was loaded into S3, and I can view my hyperparameters. Remember, those are all stored by default. And then my monitoring, again, this was a very small job that we ran. And you know what, let's actually just look at the logs. So when you're troubleshooting on SageMaker and when you're trying to figure out, you know, why did my training job do XYZ, definitely a really helpful step is just to open up CloudWatch. So from that log readout, or from the metadata on your training job, you can click into CloudWatch, and then you can see the action. Basically, we can look at the logs for that specific job. And so we can load, again, all the logs from the beginning of the job. And then you'll see we're installing the requirements here. We're downloading them. We are, again, running the environment variables and just printing out everything that's happening while that model is training. And that's your train demo. All right, and so just to close this out with some pro tips. So the first pro tip is to absolutely test your model locally. It is so efficient to take a sample of your data set, take 10% of your data set, take 15% of your data set, definitely a smaller batch, and make sure that you can get it to work locally. Whether you're doing that on Studio, or if you're doing that on a notebook instance, or if you're doing it on your laptop, do it wherever it's most efficient for you to do this, but definitely test it locally. Make sure that the model config works, that you can load it, that you have the right tokenizer, that you have some of the hyperparameters set. Run inferencing locally. Remember, in that first video, we looked at fine-tuning the model and then running inference locally. You can do that, can and should do that, again, before you scale. So before you even turn on a SageMaker training job, I really want you to just test out that model just on your laptop or on your notebook. I'm going to say this once, I'm going to say this a million times. Crawl before you walk, and then walk before you run. It is so easy to turn on too many machines and then just leave them running, and we do not want to do that. What we want to happen is we want to start, again, with success on our notebooks, then move into a small training job, move into a P3.16XL, just one of those, just one epochs. Once that works, move it to, you know, maybe 30 epochs, maybe 40 epochs, maybe add in SageMaker Training Compiler to improve the performance. Once that is operational, add your second instance, move out to 2 instances. So now you have 16 devices to play with. So you can change some of your hyperparameters, change the tensor parallel degree if you have a large model. Maybe you add in more models because you have more devices. And then once that works at a 2-node scale, then maybe you scale out to 8, and then you go to 16, and then you go to 32, and then you go to 64, and then you can really have some fun with quite a few machines on the cloud. But remember, just start small and just prove success at every scale. And the last pro tip is get your volume discounts. Like definitely every cloud provider has volume discounts. Absolutely make sure that when you look at your overall demand schedule of what types of training jobs you want to run, what types of GPUs you want to utilize, make sure that you are talking to your AWS account team, your account manager, your solution architect, your technical account manager, your specialists, and ask them for suggestions on saving money. Ask them to help you use spot instances, or to, which actually is not ideal for really large scale training just because of capacity. So it's preferred to use spot for smaller scale testing. But in any case, make sure you're very cognizant about getting all the savings that you can. Definitely, that's my pro tip. And so with that, I hope you enjoyed your training deep dive. Check out our next video, which is a deep dive on hosting with Hugging Face. Thanks.